right. හරි පුතේ. අපි එතකොට past paper discussion එකේ ඒ කියන්නේ 2025 past paper discussion එකේ part 2 එක. Right, so we are starting 2025 past paper discussion part 2. So we finish actually the part 1, so we are starting with the part 2, right? Structured essay, and we'll discuss the whole structured essay and few of the important essay questions, right? Right. So come to the structured essay 1. Microorganisms can be classified into two groups, prokaryotes and eukaryotes, based on their features. Answer all the following questions with regard to the microorganisms given in the box below. Right? So these are the microorganisms given: Azotobacter, Aspergillus, Clostridium, Cyanobacteria, Lactobacillus, Nitrobacter, Saccharomyces, and Streptococcus. Right? Name a microorganism that belongs to eukaryotic group. So out of these bacteria, like you should know that out of all the microorganisms, only bacteria and archaebacteria belongs to prokaryotes, and rest of the others are eukaryotes, right? Out of all the livings, the bacteria and the archaebacteria are belonging to the prokaryotes, and rest of the algae, protozoans, then the funguses, right? They all belongs to this eukaryotes group, right? So out of these, Azotobacter, Lactobacillus, Nitrobacter, and the Clostridium, Cyanobacteria, Streptococcus, all are bacteria, right? Aspergillus is one of the algae, and it belongs to the this which part? It usually like the Aspergillus belongs to protozoans. Basically, they belong to protozoans. So like Aspergillus is one of the eukaryotes, and Saccharomyces is one of the yeast. Like Saccharomyces is yeast and is one of the funguses, right? So Aspergillus and fungus belongs to eukaryote group, right? So Saccharomyces and Aspergillus, right? They both belongs to eukaryotes. Aspergillus, right? They both belongs to eukaryotes, right? So remember that out of all the microorganisms, prokaryotes and bacteria belongs to the bacteria and archaebacteria belongs to prokaryotes, and rest of all the others are eukaryotes, right? Come to this one. Choose microorganisms with the characteristics given below and fill in the table, right? These are the characteristics. Rod shape, right? So out of these microorganisms, you have to like select a microorganism belongs to these characteristics. So rod shape is basically bacillus, isn't it? So only bacillus given is Lactobacillus. The name itself has the name Lactobacillus because the bacillus is rod shape, right? The microorganism is Lactobacillus. The name itself says bacillus, right? So the name itself says bacillus. Therefore, the answer should be bacillus because bacillus is rod shape. Rod shape is bacillus. So coccus is round shape, right? Coccus is round shape, and there's spirillum, which is like a spiral. There's bacillus. There's then coccus, the round shape. Then there's spiral, right? Three of the shapes are there. Three of the main shapes are there. Right. Perform photosynthesis. So out of these ones, Aspergillus and Cyanobacteria both are responsible to, are responsible to photosynthesis, Aspergillus. Then let's check what Aspergillus is. As I remember, Aspergillus is a protozoan. Aspergillus is a fungi. I'm sorry. Aspergillus is a fungi, yeah. So Aspergillus is actually a fungi, right? Fungi. So Aspergillus and Saccharomyces both are fungi, so they belongs to eukaryotes in the first part. And now in the second one, the microorganism performs photosynthesis. Should be cyanobacteria, right? Cyanobacteria definitely performs photosynthesis, right? Then the fourth one performs obligate anaerobic respiration. So obligate anaerobic here is Clostridium. You'll have to remember all this, like you have to study the microbiology 1, 2 and 3. So you'll remember all this. Clostridium is the obligate anaerobic microorganism given, right? Clostridium. Next one, more suitable for curd production. It's basically lactobacillus, right? Lactobacillus produces this lactic acid. So it's lactobacillus, right? It's lactobacillus, right? Lactobacillus, right? Used in several industries. Well, used in several industries. Who could be that? Acidobacter aceti is basically used in acidic production. Saccharomyces is basically used in alcohol production, ethyl alcohol production. Aspergillus niger is there in industries as well. Cyanobacteria, Streptococcus. So used in several industries. Out of these, which one is used in several industries? So if you think about Saccharomyces is used in bakery production and ethyl alcohol production. We discussed both the ethyl alcohol production and bakery production under the production part of the microbiology, right? So Saccharomyces is found in few of the several industries, right? So it's Saccharomyces, right? It's of course Saccharomyces. 7. Write two similarities between prokaryotic and eukaryotic cells. Similarities. So the similarities would be they both have cell membranes. And their genetic material is basically DNA, right? Genetic material is DNA, right? The genetic material is basically DNA, right? The genetic material is DNA. So cell membrane, they both have cell membrane, and they both the genetic material is actually DNA, right? Right. Next question. Write two structural differences between prokaryotic and eukaryotic cells. So the structural differences between prokaryotic and eukaryotic. The prokaryotes have, so if we divided this as prokaryotes and eukaryotes. Prokaryotes have 70s ribosomes. 70s ribosomes. Eukaryotes have 80s ribosomes. They have 80s ribosomes. Then what else? Prokaryotes doesn't have an organized nucleus. Does not have an organized nucleus, right? The eukaryotes have organized they have an organized nucleus. An organized nucleus. They ask only two, that is enough, right? So there are few more, right? The eukaryotes have histone proteins. Prokaryotes does not have histone proteins, and their cell wall is made of prokaryote cell wall is made of peptidoglycan, and of eukaryotes it's either chitin or cellulose. Likewise, right? So those sort of differences are there. So B, answer the following question referring to the basic structure of an amino acid given. So this is the basic structure of an amino acid, right? Yeah. So circle and name the alpha carbon atom above amino acid structure. So as we discussed earlier, this is carbonyl carbon, and the carbon next to the carbonyl carbon is actually the alpha carbon. So this is the alpha carbon, right? This is called carbonyl carbon. Remember this as well. I'm telling this extra, so I'm going to write it in a red color pen. This carbon of carboxylic acid is called carbonyl carbon, right? This is called carbonyl carbon. So the carbon next to carbonyl carbon is actually alpha carbon. And if there's an amine group connected to alpha carbon, is called an alpha amino acid, right? It's called an alpha amino acid. If there's an amine acid, if there's an amine group connected to the alpha carbon, and that is called an alpha amino acid, right? Sometimes maybe what is alpha amino acid can be a question the next time, right? So, draw the structures of any two functional groups of this amino acid and write the names of those two groups in the table below. Structure of the functional group and then the name of the functional group. Okay. Draw the structures of any two functional groups. So main two functional groups are there. One is the carboxylic acid group, COOH. So you can write it C double bond O OH. The same, it's the same. And the name of the functional group is carboxylic acid. Carboxylic acid, right? Called carboxylic acid, right? Carboxylic acid. And there's this amine group, NH2 group is called amine group. Amine, called amine group, right? It's called amine group, right? Third one, draw the molecule formed when the two amino acids molecules given in B are bonded together by peptide bond. Show the peptide bond in that structure using an arrow, right? So draw the molecules formed when two amino acids molecules in B are bonded together by a peptide bond. So this is the amino acid we have, right? Yeah, B, yes. So they're asking draw the molecules formed when two amino acids molecules given in B are bonded together by a peptide bond. So we have to draw the peptide bond, right? Show the peptide bond in that structure using arrow. So this is alpha amino acid, and let's say this is NH2 group, is the NH2 group. We'll have to draw it the same way. They have expanded the bonds, right? So NH2 group is like this, and there's an R group, right? There's an R group and a hydrogen. Yeah, there's an R group and a hydrogen. Then there's carboxylic acid group, C double bond O. So the OH actually reacts, right? So OH actually reacts. We don't have to show how it reacts, right? We don't have to show how it reacts. We just only have to draw the bonds. So what actually happens is I'll draw it and erase it. So there's OH here, right? And then there's another alpha amino acid next to this, like this. Let's say N is there, H is there, another H is there. So we'll like draw it closer, little closer. Draw it a little closer. right? So N is there, H is there, H is there. C, H, R, C double bond O, OH, right? So what happens actually is OH group of the carboxylic and the hydrogen group of the NH2 is getting reacted and a water molecule is removed and forms a peptide bond. So I'm going to erase this to get to draw the peptide bond, right? So the water molecule is now removed. Now a peptide bond is formed, between two of these carbon and nitrogen, or two of these molecules, right? So this is actually the peptide bond, right? This is the peptide bond. What is this? This is the peptide bond, right? This is the peptide bond. This is the peptide bond, right? That is the peptide bond. Right. Come to the next one. Write the name of an essential amino acid, right? So there are 9 essential amino acids, right? There are 9 essential amino acids. You'll have to remember all the 9 essential amino acids, and I have given you a list of it, right? So we will write the whole list of it and like at least try to remember 1 or 2, right? It's better if you can remember all the 9 amino acids. So it's histidine, yeah. So histidine, isoleucine, right? Isoleucine, then leucine, then lysine, then lysine. You'll have to remember all this, huh? Lysine, then methionine, right? Methionine, phenylalanine, right? Phenylalanine, right? Phenylalanine, threonine, right? Threonine, then tryptophan, right? Tryptophan, right? Tryptophan. Then valine. Tryptophan has a H here. Tryptophan has a H here. Tryptophan. Then valine, right? So these are the 9 amino acids. You have to remember. So they're asking only one, huh? So I just wrote everything because if you need it as a note, just remember that you'll have to remember all the 9 amino acids. Huh? You'll have to remember all the 9 amino acids, right? Come to the next question. Name a chemical test that can be used to identify amino acids. It's ninhydrin test, right? Ninhydrin test. You had to do ninhydrin test to identify amino acids. Just like in the ninhydrin test, what actually happens is it gives a purplish blue color change, right? It changes the color into purplish blue when you apply it, if the amino acids are present. Second, a student designed an experiment to determine the amount of energy required and the reaction rate of the production process of biodiesel. In this experiment, 100 milliliter of used coconut oil is mixed with 1 gram of KOH into 100 milliliter of ethanol. Then the mixture is heated to 60 degrees of Celsius. What is the function of KOH in this process? Hold on. Determine the energy required and the reaction rate of production process of biodiesel. Okay. So biodiesel is produced reacting ethanol and triglycerides. right? So the KOH is actually the catalyst there, right? Is the catalyst, right? What is the function of KOH in this process? Is actually the catalyst, right? It's the catalyst. KOH is the catalyst. Why is it not suitable to heat the mixture beyond 60 degrees of Celsius? Because ethanol will evaporate, isn't it? Right? Because ethanol is volatile and it will eventually evaporate if you heat it above 60 degrees of Celsius, right? Ethanol will evaporate, or the rate of ethanol evaporation will be high. Sort of an answer will be acceptable, right? A metal object with a heat capacity of 500 joules per Celsius at 40 degrees Celsius is placed in the mixture, right? The temperature of the mixture increase from 30 degrees to 32 degrees of Celsius. Calculate the heat capacity of the mixture in kilojoules per Celsius, right? So what happens here? Now they drops a metal object, right? Let's say this is the metal object. Its heat capacity is C is 500, right, joule per Celsius, and is at 40 degrees of Celsius. Place in the mixture. The temperature of the mixture increased to 30 degrees of from 32. So the mixture temperature was increased to from 30 to 32 degrees of Celsius, right? Calculate the heat capacity of the mixture in kilojoules per Celsius. So basically, the heat released, right? Heat released by the metal should equal to, right? Should equal to the heat absorbed by the mixture, right? Heat absorbed by the mixture. So if it is like mixture method, this is the equation. If there are like more than one or two things that absorb the heat, you'll have to write everything. But in this case, it hasn't mentioned any of the containers absorbing the heat, right? So we will take it this way. Heat released by the metal is equal to heat absorbed, right? Heat absorbed by the mixture, right? By the mixture. So heat released by the metal is its C theta. So the C is given and the temperature difference is 500 into 40 minus 32, because as it says the 30 degrees is increased up to 32 degrees of Celsius, which means this is the equilibrium of temperature, right? Because when a mixture, like when you mix two of the things in two different temperatures, they will transfer heat and will come to an equilibrium of temperature. So this is supposed to be the temperature of equilibrium, right? So it stops there. So 40 minus 32 is the temperature difference of it, equals to C theta of the mixture. So I'll take the C as C, and the temperature difference of the mixture is 32 minus 30, right? 32 minus 30, which is 2. So this is 8. The 40 minus 32 is 8, and 32 minus 30 is 2. 2 times 1 to 2 times 4. So C equals 4 times 500 is 2000 joules per Celsius, right? It's this is 2000 joules per Celsius, right? 2000 joules per Celsius should be the answer, right? Come to the next question, fourth question. Calculate the amount of heat required to raise the temperature of the mixture to 60 degrees of Celsius, assuming the initial temperature of the mixture is 30 degrees of Celsius, right? Amount of heat required to raise the temperature of the mixture to 60 degrees of Celsius. So it's basically Q equals C theta. So now you already know the C, and it says the temperature from 30 to 60 degrees, right? So you just have to apply the formula. So the C is 2000, theta is 60 minus 30, which is 30. So 30 into 2000 is, it's 6 into 4 of the zeros, 1, 2, 3, 4 joules, or 60 kilojoules, right? 60 kilojoules. The reaction between coconut oil and ethanol in the production of biodiesel is as shown below. 3 ethanol molecules plus 1 coconut molecule produces 3 biodiesel molecules plus 1 glycerol molecule, right? The initial number of moles of ethanol in the mixture is 3.5. Calculate the concentration of ethanol in the mixture, right? Assuming that the addition of KOH does not cause any change in volume, right? So initial number of moles of ethanol in the mixture is 3.5, right? They have 3.5 moles of ethanol. Calculate the concentration of ethanol in the mixture. So what is the volume of the mixture anyways now? As it mentioned there. Have they mentioned the volume? Yeah. In the mixture they are asking, right? The student designed an experiment to determine the amount of energy required and the reaction rate of the production process of biodiesel. In this experiment, 800 milliliter of used coconut oil is mixed with 1 gram of KOH in 200 milliliter of ethanol. Then the mixture is heated. They are asking the ethanol concentration in mixture. So it's 200 plus 800 altogether. It's 1000 milliliters, which is 1 decimeter, right? They're asking the concentration of ethanol in the mixture. So basically the concentration is equal to number of moles over the volume in decimeters. So the number of moles are 3.5 moles divided by the volume is 1000 milliliters, which is 1 decimeter. So the concentration is actually 3.5 mol dm minus 3. This is the concentration, right? 3.5 mol dm minus 3 is the concentration, right? The amount of ethanol remains in the mixture after 100 minutes is 1.0 moles, right? Calculate the rate of ethanol consumption in mole per minute. The amount of ethanol remains in the mixture after 100 minutes is 1 mole. So if I write it in this way, so initial, right? Initially, CH3 CH2OH or the ethanol was 3.5, right? And how much has reacted? And final. So it says finally there's 1 mole remaining. There's 1 mole remaining, which means how much has reacted? Out of 3.5, 2.5 has reacted, isn't it? Right? Out of 3.5, 2.5 has reacted. That's how 1 mole is left, right? So this is the amount reacted, right? Reacted amount is 2.5 moles. And it says the reaction occurred in 100 minutes of time. So they are asking the rate of consumption of ethanol. So our rate of consumption of ethanol, right? C2H5OH should equal to delta concentration difference of C2H5OH divided by time. So as the given detail, the concentration difference is final minus initial, right? Final minus initial. This is production rate they're asking, right? Sorry, consumption rate. So if it is consumption rate, you have to put a minus in the front. If it is a consumption rate, because the reactants are consumed, so the reaction rate becomes a minus value. To make it a positive value in the formula, you have to put a minus value in the front, right? So this is the minus value I put. So minus, you have to take 1 is the final value, final amount, and the initial amount is 3.5. So final minus initial, right? Mole per cubic decimeter, so it's the same, right? Divide by the time is 100 minutes. So it's 2.5 divided by 100. That will be 2.5 divided by 100 is 2.5 into 10 to the power minus 2 mole per minute, right? Mole per minute. 2.5 into 10 to the power minus 2 mole per minute, right? Third question. Calculate the yield of biodiesel of this process in moles, right? Calculate the yield of biodiesel of this process in moles. Yield of biodiesel. That should be the amount of biodiesel produced, right? Compared to the amount of like the reactants reacted. So calculate the yield of biodiesel of this process in moles. They're asking in the like yield is, they're not asking in a percentage, I hope, because this much was reacted, this much was produced. Biodiesel yield, in the sense they're asking the amount of biodiesel produced, right? So biodiesel, so the reaction is like this. As it was given in the, this one, 3 ethanol molecules plus 1 coconut oil molecule gives 3 biodiesel molecules. So as per the chemical formula, the stoichiometry of consumption of ethanol and production of biodiesel are 3 to 3, which is 1 to 1. So if 1 mole reacts, 1 mole is produced, right? That is, you call the stoichiometric ratio. Stoichiometric ratio is 3 to 3 to 3. Do you understand that? This is 3, this is 3 as well, which means if 3 of this reacts, 3 of this is produced, which means if 1 of this reacts, 1 of this produces. So the stoichiometric ratio of consumption and production is 1 to 1. So I'll write this, right? So ethanol and biodiesel, right? Stoichiometric ratio is 3 is to 3, which means it's 1 to 1. So if 2.5 mole reacts, right? 2.5 mole of biodiesel is produced, right? Is produced, right? If 2.5 moles of ethanol, right? If 2.5 mole of ethanol reacts, 2.5 moles of biodiesel is produced, because if this is 3 to 3, it means it is 1 to 1, right? It means it is 1 to 1. 3 is to 3 is 1 is to 1, right? Calculate the rate of biodiesel production in mole per minute. So it's the same rate. So rate of, rate of biodiesel production is equal to what? Rate of consumption of ethanol, right? Because their stoichiometry is 3 is to 3, right? Stoichiometry, because their stoichiometry is 3 is to 3 or 1 is to 1, right? Therefore, the rate of production of biodiesel or biodiesel is also the same. How much? How much did you calculate? 2.5 into 10 to the power minus 2. 2.5 into 10 to the power minus 2 mole per cubic decimeter. Right? This should be the answer. Correct? Right. Come to the next one. Calculate the amount of energy that can be produced by combustion of biodiesel generated during the first 100 minutes. So we know the amount produced in the first 100 minutes is 2.5 moles, right? 2.5 moles of biodiesel. The heat energy released from the combustion of mole of biodiesel is 2.5 megajoules. So they are asking calculate the amount of energy that can be produced by combustion of biodiesel generated during the first 100 meters. The amount of moles produced in 100 minutes is how much? 2.5 moles, right? And the energy produced, right? Energy produced per mole of biodiesel is 2.5 megajoules, right? You have to find how much of energy is produced to produced for 2.5, right? So energy produced for 2.5 moles of biodiesel. That will be achara mecharana mecharada kochchadadu, right? Simple as that. Achara mecharana mecharada kochchadadu, which means if for 1 mole 2.5 megajoules were produced, right? Per 1 mole 2.5 megajoule were produced. How much can be produced per 2.5 mole of biodiesel? Per 1 mole of biodiesel, 2.5 megajoules are produced. For 2.5 moles of biodiesel, how much of energy is produced? So you have to multiply 2.5 into 2.5. So 25 into 25 is 625. So that will be 6.25, right? 6.25 megajoules, right? Megajoules. 6.25 megajoules. Third question. Lipids are one of the main nutrients in the food and are mainly composed of fats and oils, right? Sorry, fats and oils. Composed of fats and oils. Okay. Coconut oil and palm oil are common edible oils used in cooking, right? Coconut oil and palm oil are common edible oils used in cooking, right? What is the main difference between fats and oils? So fats are solid in room temperature, right? Fats are solid or semi-solid in room temperature, right? Room temperature, right? Fats are solid in room temperature, and fats are solid in room temperature. What else? What else we can say about the fats? There's something came to my mind and left. Fats are solid in room temperature. They have high melting points compared to the oils and have high melting points, right? Relatively to the oils, huh? Oils are, let's say, oils are oils are, right, oils are liquids, in room temperature, right, in room temperature. Oils are liquids in room temperature and have low melting points, right, low melting points relatively than pets, right? Yeah, that should be the answer. So name a chemical test that can be used to identify the presence of lipid in a coconut oil sample, right? Name a chemical test that can be used to identify the presence of lipid in a coconut oil sample. That will be Sudan 3, right? Sudan 3 test, right? 3. Write the test result in the presence and absence of lipids for the chemical test you mention in part 2. Test results when lipid is present. There will be red or pink, right? Red or pink lipid globules present, right? In the presence of lipids, there will be red or pink lipid globules, right? And test results when the lipids are absent. So there will be no lipid globules, right? No red or pink lipid globules, right? There are no red or pink lipid globules, right? 4. 200 milliliter glass bottles, each separately filled with coconut oil and palm oil, were used to calculate the density of these two types of oils at 25 degrees of Celsius. Using the information provided below, calculate the density of each type of oil in gram per milliliter, right? So coconut oil, number of grams are given, palm oil, number of grams are given, and mass of 100 milliliter glass bottle with oil is also given, right? So this is mass of 100 milliliter. Sorry, yeah, 1000 milliliter glass bottle with oil, right? Right. The density of oil per gram per milliliter, right? So you just have to, like, it says 1000 milliliters per bottle, right? And mass of 1000 milliliter glass bottle is 800. Mass of 1000 milliliter glass bottle with oil is this much. So you have to reduce this by this, so you get the mass of oil, right? Because this is bottle plus oil, this is bottle only, this is again bottle plus oil, and this is bottle only. If you reduce the bottle mass by the total mass with bottle and oil, you'll get the mass of oil. And but still the oil volume will be 1000 milliliters. So mass divided by volume gives you the density, right? Mass divided by volume gives you the density. So I have to find the density, right? Calculate the density of each type of oil, right? So it's 1718 minus 800 divided by 1000. This is gram, this is milliliter. You have to find it in gram per milliliter. So yeah, fine. And this is 1692 minus 800 gram divided by 1000 milliliter. And the answers you should write, right? Shall we simplify this quickly and write? Can you simplify and quickly tell me? Yeah, so two of the values are 0.918, 0.918 and 0.892, right? 0.892 gram per milliliter, gram per milliliter, right? Those are the two values. Right. Saturated fatty acids molecules are tightly packed together based on the calculated density values. Determine the type of oil that contains more saturated fatty acids. Right. Saturated fatty acid molecules are tightly packed together based on the calculated density values. Determine the type of oil that contains more saturated fatty acids. So more saturated fatty acids means more fat, right? Saturated means fat, unsaturated means oil. Remember that, we discussed it. Like if all of the carbons are having single bonds with each and every atoms available, you call it saturated. Like saturated in the sense they have made the possible number, the maximum number of bonds within each other, that is saturated. Everything is saturated, nothing left to have more bonds. But if it has any of a double bond, it means it has more space to make more bonds, because if you break one double bond, break one double bond, you can make two more extra bonds, right? If you break a double bond, you can make two more extra bonds, right? Two more extra bonds, which means this is saturated, this is unsaturated. Like if there's a double bond, it's unsaturated, right? And remember that unsaturated are oils, these are oils, and saturated are fats, right? These are fats and these are saturated. All the bonds are saturated, and there's more bonds that can make breaking the double bonds, which is unsaturated, and they are oils. Remember that this is unsaturated oils, saturated fats, right? Saturated fatty acid molecules are tightly packed together based on the calculated density values. Determine the type of oil that contains more saturated fatty acids. So if something contains more saturated fatty acid, its density should be high, right? So which should be uh, coconut oil, right? They are asking determine the type of oil that contains more saturated fatty acid. Is the coconut oil, of course, right? Because more density is there, right? Coconut oils, right? It should be coconut oils. Right. Right. So the next one. Masses of mixtures of coconut oil and palm oil mixed in different ratios are given in the table below. Plot the volume of coconut oil versus mass of each mixture in a grid given below. You have to plot this, right? Mass of, right? Plot the volume of coconut oil, right? Volume of coconut oil and mass of each mixture, right? Volume and mass. 1000 here. So they're asking what the volume of coconut oil versus mass of each mixture. Okay. Mass of each mixture in the grid. So in one of axis, you have to take the volume of coconut oil, then milliliter. Does it say masses of mixtures of coconut oil and palm oil mixed in different ratios? Okay. Masses of mixtures of coconut oil and palm oil are mixed in different ratios are given in the table below. Okay, so the mass in grams are given. That should be the mass of the mixture, and these are the volumes mixed, right? 100, 800, like 1000 of the coconut oil, 800 volume of coconut oil with 200 volume of palm oil, and the mass is this much. So likewise, you have to plot the graph by putting the values like let's take 5 by 5. Can we? I hope we can. 1, 1, 2, 3, 4, 5 are there. So we'll take 10 by 10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So likewise. Right. 3, 6, 7. And 10, right? So in this axis, you have to put the volumes, and in this axis, you have to put the masses, right? So here it should be here. The volumes are from 0 to 1000, and the masses are from somewhat 918, right? 918 from 892. So that is also 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So all are 6 ne. Make it 0 ඉඳන් what are the 200 400 විදිහට මේක ගන්න පුළුවන් ඉතින් මේක volumes ටික න. Does it mention the axis? No need. Plot the volume of coconut oil versus mass of each mixture. Yeah. So it's 200, 400, 600, 800 and 1000, and there are 6 of it here. I'll take how 92, 97, that is 5, 902, that is 5. So it goes 5 by 5, isn't it? Goes 5 by 5. So I'll take it, this is 10, ne? 3, 6, yeah. 3, 6, 8. I'll take 5 by 5. So I'll like squeeze this, and I'll take the minimum value here, 892, and we'll go 5 by 5. 892. Then again 897, 902, 907, then 9012, sorry, 9112, right? 9112 is the last value. There's another one. 918 is also there. So make it 7 add 9 sorry 5 add වුණාම පස්සේ 917 වෙන්න ඕන, but the graph goes up to here. හොඳයි 918 වෙනකන් යනවා. So if you plot them, coconut oil එකත් එක්කනේ 0 වලදී 9892 මෙහෙම යන්නේ 0 වලදී 892 then 200 වලදී 897 200 sorry 0 වලදී coconut oil 0 කියන්නේ 892 ඒ කියන්නේ මෙතන නම් යන්නේ නේ 892 0 වලදී ඊට පස්සේ 792 කියන්නේ 200 හරි 792 කියන්නේ 200 sorry 897 කියන්නේ 200 902 කියන්නේ 400 likewise ඊට පස්සේ ටික ටික එහෙම වැඩි වෙනවා then 907 කියන්නේ මෙයා 912 කියන්නේ මෙයා ඊට 917 කියලා කියන්නේ මෙයා right 917 නේ 918 කියන්නේ මෙන්න මේ හරියට එන්නේ හරි 990 if you draw the graph it will be something like this straight line එකක් එනවනේ something like that on home plot එකක් එන්නේ හරි මේවා හරියට axis name කරන්න volume of coconut oil also should be there mass of the mixture mass of the mixture right mass of the mixture right right a student bought 1000 milliliter of coconut oil from the market and its mass is 900 grams. It is suspected that this coconut oil is adulterated in the sense like they have put something which looks like, which appears like, which sounds like the coconut oil but is cheaper, and something is not coconut oil, right? They have adulterated it. They have put something looks like coconut oil but not coconut oil, right? Adulterated with palm oil. So determine the possible volume of palm oil in this sample using the graph drawn in 6 above. So student bought 1000 milliliter of coconut oil from the market and its mass is 900. Okay, if the mass is 900, the volume should be somewhere here, right? The volume should be, this is 10 in between, right? 3, 6, 9, yeah, 10. So 400 to 600, there's 10 shells, 1, 2, 3, 4, 5. So it's half of it, of course. So it's 500, right? It will be 500 milliliters, right? If it is 900 grams, should be 500 milliliters. Run about 1000 milliliter of coconut oil and the market and its mass is 900 grams. It is suspected that the coconut oil is adulterated with the palm oil. Determine the possible volume of palm oil in this sample using the graph. So it should be this, and this is 500 milliliters, right? Should be 500 milliliters, close to, right? We'll take like approximately 500 milliliters, right? Right. You have to take it from the graph. So 900 එකේ ඉඳන් බලන්න. 900 මෙන්න මෙහි තියෙනනේ. එතකොට 500 නෙමෙයි. මේ 907 නේ. 902 මෙන්න මේ හරිය තියෙන්නේ. මේ හරිය කියලා කියන්නේ මෙහි තියෙන්නේ. It should be somewhere here. Not here. I'm sorry. Not 500. Take a different color. මෙතන 902 මේ හරිය 900 එතකොට. I draw this. So it should be somewhere here. So මේක 10 කරනේ. So 1 2 3 7. 7 කියලා කියන්නේ so it's 200 නේ 10 කියලා කියන්නේ. එතකොට එකක් වෙනවා 20 20 ඒවා 7 කියලා කියන්නේ 140 20 over 7 කියන්නේ 140 so 340 නේ එන්න මේ point එක එන්නේ 340 milliliters right 340 milliliters right? It should be 340 milliliters approximately right the approximate value should be 340 milliliters right so come to this one. A commonly found lipid molecule is shown below, right? Using an arrow, mark an ester bond in the lipid molecule. මේකේ ester එක හැදෙන්නේ කොතනද? වෙන්නේ මොකක්ද? So what actually happens is there's a triglyceride, හරිද? CH2OH, CHOH and CH2OH. This is a triglyceride. And this reacts with a carboxylic acid, right? Carboxylic acid, or you call it a fatty acid. Carboxylic acid එකත් එක්ක තමයි react කරන්නේ. You call it a fatty acid. So 3 of the fatty acids are reacting, right? So when the reaction occurs, it's actually the OH of the carboxylic reacts with the hydrogen of the glycerol and removes the water molecule, right? So the bond occurs between the oxygen of glycerol and the carbon of carboxylic acid, right? Between the carbon of carboxylic acid, the bond actually occurs between the carbon of carboxylic acid and the oxygen of glycerol. So it should be this one, right? It should be this one. So this is a ester bond, right? Ester, right? So 3 of this likewise will come and will do the same way of reaction. So 3 of the esters are there. But esters තුනක් තියෙනවා. Now then this is ester as well. Then this is ester as well, right? මේ තුන් දෙනාම ester. Right? මේ තුන් දෙනාම esters. මේ තුන් දෙනාම esters. Right. Likewise මෙතන තුන් දෙනෙක් යනවා. Right. Identify and draw the structures of one of the fatty acid molecules and the glycerol molecule that the lipid molecule is made of in the given boxes. Fatty acid molecule. මේ carbon number එකක් නම් fatty acids වල දීලා නැහැ නේද? Commonly found lipid molecule is shown below. Okay. මේක fatty acid එක අඳන හරි. මේ bends ගාන අඳින්න හොඳ. මේ bends ගාන හරියට අඳින්න වෙනවා. මොකද each bend represents one carbon නා. ඒතර මෙතන තියෙනවා chain එකේ 1 2 3 4 5 6 carbons තියෙනවා. හොඳ. Each bend represents one carbon. So මෙයාගේ තියෙනවා 1 2 3 4 5 6 7 8 9 carbon තියෙනවා මෙයාගේ. මෙයාගේ තියෙනවා 1 2 3 it starts from here, right? Yeah, it starts from here. 1 2 3 4 5 6 7 8 9 10 carbon තියෙනවා මෙයාගේ. So identify and draw the structure of one of the fatty acids molecules and the glycerol molecule that the lipid molecule is made of in the given boxes. So we'll identify one of the fatty acids, this one. So it has 1 2 3 4 5 6 carbons. So we'll draw it the same way. So C double bond O. OH should be at the end. There's this bend, this bend, this bend, this bend, this bend, this bend, and this, right? So all these are carbons, right? All these are carbons, right? All these are carbon atoms, right? So this is the first one. And there's now glycerol molecule, right? There's now glycerol molecule. Okay. So glycerol molecule will be same, right? So do we have to draw it the same way, like it's there in the structure? Identify and draw the structures of one of the fatty acids and molecules, fatty acid molecules, and the glycerol molecules that the lipid molecule is made of. The given boxes, fatty acid molecules. If I like draw with the carbons, it will be different, right? Be something like this. C double bond O, OH. So there's one carbon here, one carbon here, one carbon here, one carbon here, 1, 2, 3, 4, 5, 6, likewise 1, 2, 3, 4, 5, 6, right? This is how the carbons will be there, and rest of the atoms will be hydrogens. Basically, if you draw this one, it is correct as well. And if you are to like expand the bonds, this is how you draw it, right? Because each carbon gets to have 2 of the hydrogens, and each carbon gets to have 4 of the bonds, because each carbon has like 2 bonds already. So the final one gets to have like 3 of the hydrogens. Because each of the carbon has 2 bonds with the carbon already, the rest of the 2 bonds available is binding with the hydrogen. So 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen, but the last one doesn't bond with 2 of the carbons, so therefore 3 of the bonds are available, so 3 hydrogens. And the glycerol molecule will be something like this. So as in this one, oxygen OH at the end, so CH2OH, then so yeah, there's another OH here in the second one, and there's another one here, right? So this is a glycerol, of course, right? 3 of the oxygens are there. If I draw it in a proper manner, like CH2OH, CHOH, and CH2OH is actually glycerol, or this one. So each and every bend represents a carbon, right? Both of the structures are correct, right? So come to the fourth one, right? Come to the fourth one. Right. So water is directed to a turbine through a horizontal tunnel connected to a reservoir filled with water up to 20 meters above the bottom, right? This setup is shown in the diagram below. Okay. The density of the water is 1000 kilograms per cubic meter. Gravitational acceleration is 10 meters per square second. The atmospheric pressure is 1.01 into 10 to the power 5 pascals, and the water level is given. Calculate the pressure at the bottom of the reservoir. So it's basically H rho G, right? P equals H rho G. So the height is actually 20 meters, rho is 1000, gravitational acceleration is 10. So it's 2 into 10 to the power 1, 2, 3, 4, 5. So 10 to the power 2 into 10 to the power 5 pascals, right? Yeah. The horizontal tunnel, what does it say? The horizontal tunnel releases an amount of 10 cubic meters per second water to the turbine. Calculate the mass of the water that travels to the turbine in 1 second. So the density of water is 1000 kilograms per cubic meter, right? This is the density. So it says per second 10 cubic meters are released, right? Which means, so the density equals mass over volume, right? I'll write it this way. Yeah, so the density equals mass over volume, right? Density equals mass over volume. D equals m over v, right? The density is 1000 kilogram per cubic decimeter. You have to find the mass. The volume is 10 cubic meters per second. So we take the 10 cubic meters. So if you cross multiply this, now the mass is equal to 10 into, sorry, 10 to the power 4 kilograms, right? 10 to the power 4 kilograms. So that is per second. This much of a mass of water is released. The opening that takes water to the turbine is located 20 meters below the water surface of the reservoir, right? The opening that takes water to the turbine is located 20 meters below the water surface of the reservoir. Calculate the speed of water that flows towards the turbine. So that should be A1 V1 equals A2 V2. So is the cross-sectional area given? No. Water is directed to a turbine through horizontal tunnel connected to the reservoir filled with water up to 20 meters above from the bottom. This setup is shown in the diagram below. Okay. Atmospheric pressure එක දීලා තියෙනවා. So basically you have to put, so the cross-sectional area isn't given, right? If the cross-sectional area isn't given, you have to put Bernoullis. That's the only option there. Or you have to convert, if you take the Bernoullis, P0, like if you consider the streamline flow of water from here to here, P0 is the atmospheric pressure, and let's consider the velocity of water flowing here is really slow, therefore the velocity is 0. So half rho v square is 0, right? P0 is atmospheric pressure, that plus h rho g should equal to half rho v square plus pressure in there. So is the pressure there is given? No, right? If you don't know the pressure here, you can't apply the Bernoullis as well, right? You're supposed to know the pressure here. So because the pressure isn't given, no, like P0 plus half rho v square equals h rho g plus half rho v square. And you're supposed to know the pressure, h rho v plus h rho v plus. Yeah. So no, you can apply that. Instead, you can apply this. What? You can't apply Bernoullis here. Instead, you can apply conservation of energy. mgh is directly converted to half mv square, right? mgh directly converted into half mv square. So we'll have to ignore the atmospheric pressure here. Get it? We have to ignore the atmospheric pressure here. So ignoring atmospheric pressure, we can apply mgh of the 20 meter height water stream is converted into half mv square. Now in this case, remember that we consider the mgh is steady because the water level is slowly going down. So we consider the water is steady, because if the water isn't steady, we can't directly put mgh only. We'll have to put the Bernoullis, but we don't have enough details to put Bernoullis because we don't have the pressure here. So therefore, we're going to apply mgh equals half mv square considering that the height is keeping steady at the moment, right? So mgh equals half m square. So m to m cancels out. G is 10, h is 20 equals half into G is 10, height is 20, and v square, right? So this is 200 into 2 is 400, v square equals 400, and v is equal to 20 meters per second, right? V is equal to 20 meters per second. Oh, considering that the water enters to the turbine at a speed of 20 meters per second. Yeah, it enters 20 meters per second, yes, and exits at a speed of 3 meters per second. Calculate the kinetic energy lost per second. So it's basically half mv square minus half mv square, but even we know the mass, right? Per second mass is also there, isn't it? Yeah. No? No, we calculated in the top one, right? No, we don't know the per second mass. So what can I do? The question is asking, consider that the water enters to the turbine at a speed of 20 meters per second and exits at a speed of 3 meters per second. Calculate the kinetic energy lost per second. Okay, so the velocity, we can't take the mass as 1 and calculate this sort of thing, because the total kinetic energy actually depends on the mass, you know. So since we don't have the mass, we have a issue applying this, right? Do we have the per second mass there? I can have it is, right, this one, methane per second mass 10 to the power 4 kilograms. So yeah, we can know, right? It's basically the energy loss is half mv1 square minus half mv2 square. We have to apply half into mass is 10 to the power 4 kilograms, velocity is 20 and it's square, right, minus again half, mass is 10 to the power 4 into velocity is 3ms minus 1 square. So the kinetic energy difference, the mass we already found it, so then it's fine. You have to take the difference of this and get the value. Can somebody simplify it and tell it to me, please, quickly? Somebody simplify it and tell it to me. Put the values, right? It's 1955 100, right? 1955 100 watts, right, per second. Watts falling in joules per second. 1955 100. 1955 100. Okay, right. So consider that the kinetic energy loss of water is fully transferred to the turbine, right? Consider that the kinetic energy loss of water is fully transferred to the turbine. If the electrical output is 1.5 megawatts, calculate the efficiency of the electricity generation process, right? It says that this energy lost, the energy loss is converted to the turbine, because when the flow is going, the turbine is rotating and the kinetic energy is lost, and that lost kinetic energy is actually absorbed by the turbiner. So the energy lost is actually the energy of the turbiner, right? But still, it says consider the kinetic energy loss of water is fully transferred to the turbine. So this is the energy of turbine, right? Energy lost is actually the energy of turbine. If the electrical output is 1.5 megawatts, right? Electrical output is 1.5 megawatts, and calculate the efficiency. So this is the output, this is the input, right? So efficiency is power, I'll write it as power P, right? P out over, right? P out over P in to the 100%, right? To the 100%. And the P out is actually 1.5 megawatts. And if you divide this by 6, 1, 2, 3, 4, 5. So the in is less than out now. Can't happen. ඒක කීයද පුතේ හරියට බලලා කියන්න මේ zeros ගාන හරියද කියලා 1955 20ද 30ද 1955 30 හරිද මේක 1955 30 watts හරිද එතකොට මේක මෙගා කරොතින්ස් 10 to the power 6 නේ ඒ කියන්නේ මෙගා කියන්නේ 10 to the power 6 නේ 10 to the power 6 වලින් divide කරනවා 1 2 3 4 5 6 එතකොට එනවා 1.9 megawatts හරිද 1.9 megawatts මේ තමයි in එක මේ තියෙන්නේ out එක මේක multiply කරන්න ඕන කීයද 100% වලින් so you get the efficiency, right? And what is the efficiency now? 1.5 divided by 1.9 into 100%. Can man kiyada කියලා පරිදි කියලා කීයද දෙන්නේ 75% නේ approximately 75%, right? 75% which are තමයි approximate value එක 75%, right? 75%, right? So that's a structured essay. අපි මේක essay part එකේ අමාරුවට කියන්න අපි ටික discuss කරමු. So probably, most probably next Wednesday අපි night එකක් ගහමු හරිද full night එකක් ගහමු practical night එකක් next Wednesday අපි night එකක් ගහමු night එකක් ගහලා ඉවර කරමු ඊට පස්සේ මම තව extra papers කරනවා අපි දැනට papers 6ක් ඉවරයි model ඒවා විතරක් එතකොට next Monday අපි අපව 7th එක ලියනවා හරි ඒ වගේ දිගට තව papers ටිකක් ලියමු extra ලියලා ඉවර කරමු තව මොනා හරි ඕනේව තියෙනවා නම් කියන්න හොඳ ඒ කියන්නේ if there's anything you want to be done before the exam just tell me can do that right we have done a lot now we have done like so many things and it's you know it's more than enough right it's more than enough to make a good result and the most important thing is if you have covered all these things we did in the past few months, right? Forget what we did from the very beginning, right? Even if you forget what we did from the very beginning, Like if you think about the things that we did in the last few months, even that is enough, right? Even that is enough to to have a very good result. හරිද? අපි කරපු speed revision ටිකයි, question banks ටිකයි, model papers ටිකයි, past papers ටිකයි. ඒ ටික cover කරගත්තත් can have a good result. Right? So it's possible. Right? It's possible even now, right? Nobody has faced the exams yet, right? Everybody are still studying, and it's a matter of time, right? And the time is really relative. If you started working really hard, if you started working really hard and took the maximum out of the time you have, right? You do the hardest way you can, you take the maximum effort, maximum responsibility of it, you still can, right? You still can. That's my point. So like, don't give up. And those who are like in the good level, they're still not in the highest level, right? They're not still in the highest level, and you can go like more than this level you are now. A very huge level can be exceeded if you tried really hard now. If you do few more extra hours now, can exceed like very huge level that you are like more than that you are now. You just have to like add 1 or 2 hours extra and speed up a little bit, because you have covered so much of the things so far now. And speed up the things like manage 3 of the subjects. And if you add a little bit of more efforts, you can exceed the like huge limit of the marks, right? Maybe you are now in 65 to 70, 75 to 70 to 75, or maybe 75 to 80, or between 80 and 85. Can actually exceed this 85 level and come to the 90% level if you tried really hard within these few days. And that 90% more than of A will actually take you to a higher Z and a very huge rank in the district and in the island, right? And think of yourself being proud, being a very good rank, being a huge district rank, or being a huge island rank in the 2026 year. You can actually do that, right? You can actually do that. And I'm hoping that you will do that as well, right? So take some extra efforts, do some extra works, show the others who you are, right? Show the others who you are. Do what you can at your best, right? Good luck to everyone. Start working, do some more studies, and if you need any of our support, you need anything extra to get clarified, you want another revision, so we have done even the revisions, we have finished the theories, we have done the revisions, we have done the question banks, and if you still need something extra, just tell us. We'll do, right? I'll definitely do, and we'll hope for the best. I'm counting on you, and I'm trusting you, so do your best, right? Do your best, right? Good luck. So guys, we'll wind off for today and have another class the next week. And so we have the Tuesday class next week, and on Wednesday we'll plan to have the night, right? I'll tell about that. And the Monday we have the full paper again, and Tuesday we'll have the theory and revision class, right? Guys, see you.